Picture yourself as chlorine in a solvent. The solvent's nonpolar and you are light green. Somebody calls bromine an orangey brown and iodine's pretty purple. Lead, iodine, and chromate are yellow when the solvent is water. Look for the rose, you've got cobalt 2+, and you're gone. Sodium burning is yellow. Sodium burning is yellow. Sodium burning is yellow. CuNH3 2+ is deep blue. Iron thiocyanate 2+, blood red. Iron 3 ions are orange in water, but if there's H+, it's yellow. Tetrachloride cobaltates, cobalt blue. I2 in starch is deep blue. Burn lithium or SR and get red, capers purple. Sodium burning is yellow. Sodium burning is yellow. Sodium burning is yellow. Picture yourself as a basic solution and add phenolphthalein and turn purple pink. And silver chromate's a solid that is red. Burn copper and you'll get green. Sodium burning is yellow. Sodium burning is yellow. Sodium burning is yellow. Fudge!
Mixing a lead nitrate solution with a sodium carbonate solution creates a precipitate of lead carbonate, but sodium nitrate is soluble.
HBr, HCl, HClO4, H2SO4, HIHNO3, HBr, HCl, HClO4. What are the strongest acids? Iodic and bromic and chloric with prefix hydro, sulfuric, perchloric, and nitric acid. H2SO4, HIHNO3. How do you measure the strengths of acids? How about K? How about K? How about K? Measure Ka. Greater than 1. Greater than 1. HBr, HCl, HClO4, H2SO4, HIHNO3. This is how you measure acids.
Now that we've learned about solubility, let's learn about acids and bases. Okay, so we have a weak acid, which we'll call HA, in water. So we will have a result of a conjugate base, which we'll call H minus, A minus, and hydronium ion, which is H3O plus, and H3O plus and H plus can be used interchangeably. And so, because it doesn't dissociate completely, we need the Ka equilibrium concentration of the A minus ion, and the concentration of the H3O plus ion, or the H plus ion, divided by the concentration of the weak acid. Now we will find the pH of the solution by using a magical thing called X thingy. We will start off with an initial concentration of acid, that we will call alpha. And we know that the change in the concentration of the acid is going to equal the change in the concentration of the conjugate base, and that also equals the change in the concentration of H plus or H3O plus, and we will call that change X. From this, we can write our equilibrium equation because the system is in equilibrium. And so we have X for the amount of conjugate base times X for the amount of hydronium ion. And then all that is going to be over alpha minus X. Remember, the fate of the world hangs in our pre-lab calculations and test tubes.
Solubility in acids and bases are cool, but can we just blow the ring up?
Remember lab safety, guys!
And in that crucial moment when our surviving heroes were on the brink of success, disaster struck. Lord Arrhenius distracted them and they were unable to explode the ring. But then, when all hope was lost, Gollum took up his father's sword and threw the ring into the fume hood and lit the flame.
So that's what's left of the ring, huh? Yeah, poor Gollum.
Yeah.